Okay, so the question wants us to find the gradient of the tangent to y equals x plus 1 over x all to the power of 3 at x equals 1. So I'm going to write y in terms of powers of x just so it's easier to differentiate afterwards. Okay, now we're all set. So we're going to use the chain rule. And the chain rule basically says, okay, so let's differentiate whatever is in this bracket and then multiply it by the derivative of the whole thing. So let's say y is equal to u cubed. Well then, dy over du is equal to 3u squared. Now, let's also imagine that, so we're imagining that u is equal to x plus x power of negative 1. Well then, du over dx would be 1 minus 1 over x squared, because it's 1 minus x power of negative 2, which is 1 minus 1 over x squared. And if we multiply dy over du by du over dx, the du's cancel out. We get dy over dx, which is essentially what we want to find. So dy over dx is du over dx, which is 1 minus 1 over x squared, times dy over dx, which is 3u squared. Sorry, dy over du, which is equal to 1 minus 1 over x squared times 3 times u squared. So u, as we can recall, was x plus 1 over x, and we're squaring that. So this is our differentiated function, and luckily we don't need to simplify further. All we need to do is substitute 1 into our into dy over dx to find the gradient at that function at that point. So m is equal to, and then we substitute 1, we get 1 minus 1 over 1 times 3 times 1 plus 1 over 1 squared. Now, these two values could have a value. That doesn't really matter, actually, though, because this value over here is 1 minus 1, which is 0. So anything but multiplied by 0 is just 0. So our gradient is m is equal to 0. And if we want to take it a step further, we could imagine that this is basically a stationary point. So this could be a maximum, a minimum, or an inflection point. And if you use the second derivative test, you could go further to find out. But since this is only asking for the gradient, we can just say the gradient at x equals 1 is 0.